So first of all, we are going to take a look at where we were with platformer. I think I don't remember. This is just a map here, and I think we gotta go in version 1. There it is. We were just jumping up and down with this little sprites, and when he hit this rectangle here, it detects a collision that you see will print something here, make this rectangle going red. And now we are going to see where we will arrive with the new version. There is, I think, this thing here, platform 2, some adjustment here, a lot of things to change. Here it is where we want to arrive to. A little guy here jumping up and down. This time it has a map and it not jumps every time, but just when we push a button. So okay, let's close it and let's see what we done. The fluffy potato, I made some changes to, and let's see first how he scaled the screen. So the screen is 600 for 400, but then let me put this up. Then this, here it is. It's 400. Sorry, for 600 for 400, and then we have this. It creates this surface. So the window is 600 for 400. As you can see, this is 600 for 400. But with display here, we create a surface that is 300 for 200. So now we will just bleed our sprites into this little tiny window. So it will be a window inside this greater window. It's a surface. There is half a quarter of this one. So, but if you see here, we have it displaying it on all the 600 for 400. So what happened? There is a scale. So this will be the surface where we will bleed everything. Okay, and then we will scale every frame the display onto the screen. Okay, so I don't know if it can work like this. Yes, doesn't matter the order. So now if we go to see where the skin will be scaled, we are in the while loop here, the thing that makes the sprites move, etc. every 60 frames a second. Let me write, what is this? Tiles are bleated. We will see this later. So this is for the tiles, and we were talking about, okay, the screen bleed. So first I told you, here we got display fields. As you can see here, we will fill of this bluish color here, see on something like this, on the display, no more on the screen. In fact, if you could check the version 1, you will see that screen here, okay, is set to 600. Well, it was 400, doesn't matter. And then we used the screen fill, screen bleed instead now. Instead now, we, if I find again the file I was using, there it is, platformer 2 I called it. Let me change the name to version 2 so that I remember what I'm doing. Okay, version 2 is it uses the display surface as the where to put all the things. So we will see here display bleed, display fill to clear the screen. This clear the screen. This draw the map, and this takes care of the movement of the player. Right, so this is the jumping thing like that. Collision, this detects collision, we will see it later. And this occupies over the collision. This is the movement. This is the how to show. I added these, I don't know how the Fluffy did it. Show flip, oh, alright, flip the player image when goes to the left, right? Because the image, okay, we will see this later. And here it is, the screen. Now this is the screen where I bleed the display that is transformed and scaled to the Windows sides, starting at 0, 0. Okay, so this means that I take the surface that is 300 for 200, I bleed it onto the screen that is 600 for 400, and I scale it to from 300 for 200 to 600 for 400. That is the Windows sides here. This Windows sides contains the tuple, and 600 for 400, and at 0, 0. So the result is this, that is, it should be a stretched window, instead it is big. Because if, for example, here I change to another tuple here of the same size of the 300 for 200, you see that I will have the amount of, okay, this is the actual resolution. Instead I doubled it. I can do even something in between, like 400 and 300. It will be a little bigger. If I go instead to the actual stuff here, it will fully cover all the image, and it will start at 0, 0. If I put here 100, it will be a little, you see, a black space is a little bit on the right. Okay, so we have seen Pygame transform scale thing. Now let's see how I change the using the same sprite. I go left and right. You see, it turns left and right. I made this thing here. I'll try to be very fast. So I'll put stay right equal true to take trace to monitor the where he is facing. So it is stay right. So it starts facing on with the facing the right side of the screen. So when if I go here, when moving right is true, stay right will be true. So you'll be, I won't change anything. When it's moving left, stay right is false. And where I use this boolean value here, I use it where I blit the player image, of course. So in the version 1, the player was always, if you saw here, it's always looking on the right, even if it goes on the left. It's a little tiny, you can see it, but and so in the while loop here, the screen blit player image at a certain location, right? That was always on the left, looking on the right. Now in version 2, I got if I this display blit, display instead of screen, because now I'm blitting on the display that will then be blitted on the screen, scaled, the player image and the location here, that this time, I don't know why, I use it play underscore act dot x and play underscore act dot y, and location, I don't know why it changed. There is no more location for the location. Should be somewhere. Location. There is no more location. Okay. But there is this player rect because player rect, I wanna remember you, that is this thing here. Let me put a space after a comma like the rules say. And so the player rect is the starting position here of the sprite. That is a position 100 100. It is 5 of white and 13 of height. Another thing that I don't know if there was in the first version is this convert thing here. Player image, yes, there was no convert thing. This convert thing makes me then set the color key white to transparent. I could have done another thing. I could have gone to this sprite here and open it with Paint.net, for example. Go and delete this stuff. I'm deleting it? No, I'm not deleting it. I'm coloring. transparent, not so transparent. Okay, and let me take away the, I can make a couple of eyes here, but leave it this way. Okay, now that I made it transparent, I'm gonna save it, substitute the old one, and now I think I can always avoid using this convert and set color key, etc. Should work. Okay, so I don't know which one was faster. Well, I leave it this way, doesn't matter. So what I just did was that if stay right is true, it will play the normal player image. Instead, if stay right is false, it means that going to the left, it will use this pygame transform.flip player image 1 0. The one means that is flipped to the left. It's flipped, and this one means that it's not flipped up and down. It could be flipped also up and down. If I go like this, you will see what happens. When it goes to the left, it will be upside down, but we don't want this in this case, so it will be 0. So what we have done, and then we need to explain the jumping stuff. So we have the key down will be right, left, and key up. If you see the key up here, if you press the key up, or I would like to use the space more than key up, and I don't know if it's space. I think yes. There we go. if you press space, if our timer is less than 5, momentum equal -5. So air timer is this variable that must be less than 5. That's less than 6. Here you can see the collision with the collision bottom equal true, air timer equals 0, momentum equals 0. So this means that if it hits the floor, it will stop falling down and also stop jumping, else air timer plus equal 1. So it will stop. It will continue to fall if there is no collision with the bottom. So here player acts in collision will take its value from move when it passed player rect, the position of the player movement, that is the right in the left and left rect stuff. So you see here that it continues to, this momentum, it continues to fall. And so player rect and collision. Let's go to move, player rect, movement in tiles. So collision types, top equal false, bottom false, red false. It start with no collision, but rect dot x plus equal movement 0. So the movement is passed here by player movement, and the player movement is equal to 0, 0. But if moving right is equal to player movement 0 is plus 2. If moving left, player movement 0 is minus 2. Player movement 1 instead, that is the vertical stuff, is plus equal momentum. And momentum starts from 0. Then momentum is increased of 0 to when it falls down. If momentum is major than 3, momentum is equal to 3. So let's see what happens here with the, you see it falls down. When it hits something, it stops. Okay, let's jump. You see that there is this momentum 0, 2, and then 3. I think it's this falling down. You see it's falling down with this. unfolds very quietly. Instead here it is stopped like a moment. Okay. Let's try to change this. Because it goes soon to 3, so if I do 3 instead 0 2, this will jump a little less. This will fall down faster. Okay. So this momentum is what makes him fall. And let me see here if collision button equal true, because we go here and we send the player position and the player movement. So here rect.x plus equal movement. So it takes care of the movements. I don't know what. Let's put a 0 here. It's a tuple, it's not a. Doesn't move. So the player movement here increases of 2 and then turn to 0. Okay, so rectx equal movement 0, so it's like the player movement. And hit list collision text, here it tests if the rectangle collides, that is this thing here, collides with the tiles. The rect is the player practically. And for tile in hit list, so now the hit list contains all the tiles. The tiles are here. The tiles are the tiles rect here. The tile rects are the list of all the rectangle with their positions. So every tile has its position, and it is a rectangle object. that is in this list tile rex that goes here with the name of tiles, and it it looks for all the it goes here, the collision test sends direct and all the position of the tiles, and here for every tile in this list of tiles, if the player collide rect, if collides with if the rectangle collides with one of these tiles, it will be appended in the hit list, and then returns the hit list to here. So this hit list here contains the fact that there is a collision. I think that this one returns a true or false thing, I think. Okay, it returns the rectangle on which, okay, the rectangle is 16 is the width and height, and this is the position of where the player is colliding. So returns the so and so the so the hit list return this rectangle, or one or more rectangle with all the stuff with which the player goes in contact. And if movement is major than 0, so it is, if it's going on the right, I think we could also use if moving right, maybe could be the same. Where oh wait, okay, if major than 0, rect right equal tile left. So it will stop. I cannot use moving right probably because I should put it here like a, yeah, like a global. Okay, and it stops practically. So the collision types is equal right, So if it is moving towards right and there is this collision, it means that the collision type is right. If movement is minus than 0, it means that the collision is left. Then it goes to the movement on the Y, hit list collision text. It makes again collision text from the player and the tiles. And for tile hit list, this time, if movement 1 is major than 0, it means that if it's falling down, rect dot bottom type equal tile top, it stops. So the rectangle here, the player, will stop and the collision type will be bottom. And the rect bottom is the player rectangle here. Okay, it's and gets the same what I did here. Gets the same coordinates of the tile top. It means this is the tile with which he had the collision. So the coordinates of the rect bottom is equal to the tile top. So the collision is bottom. If it's minus than 0, means that it's going up, it's jumping, and so the rect top will be equal tile bottom. It's the opposite. The top of the player will be the same position of the tile's bottom, and collision type will be top, will be true. So it will return the rect, that is the position here of the rectangle of the rectangle surface of the player, and the collision types will be top, bottom, left, and right. So when he goes back here, to if collision bottom equal true, air timer equals 0, so a momentum 0, it means that it will stop falling down, else air timer plus equal 1, it means that it will continue to fall down if the collision is to the bottom. And so this is what stops from falling. And this is what stops from going right and left. Let me try to comment this and see what happens. You see, if I go on the left, is everything fine. If I collide here, you get this strange behavior of, it goes up because and I cannot jump either. If I do comment also this, get the same behavior on left and right, and I can't jump. Okay, and so let me uncomment and uncomment, start, go, and now it works. Oh yes, it can jump because I changed the button. And when I go here, you see that I cannot go here. And if instead here, let me rect bottom equal to top, rect top. If I comment this, you see that when I jump and I do not stop. I continue to go up, but they cannot go down. If I comment this, I got a very strange behavior. Because, okay, so now let me uncomment everything and everything will be fine. Okay, so that is a little bit of explanation trying to understand how this works. And so now we have to explain the last part here, the game map. So how we show this map here. The skeleton, the blueprint of the map is this sequel of characters here. We get a multi-line string, and here on each line, this is, for example, the grass. This is the dirt. This is a grass with a rounded corner on the right. This is the grass with a rounded corner on the left. And so it gives you this map here. You see the round corner here, and the dirt and the grass one thing here. Okay, there is also, I can change this into one with the grass. And so these multi-line strings will be transformed into a list of strings with split lines. So in each one of these become a something like this, become a list with this thing inside for each line, and then I transform with this comprehensive list. This is a for loop made in this way, like a comprehensive list. It's the same thing of for loop that you can see here for M in game map. It will, if you do, you could have done also for each M in game map. It means for each list, for each list in game map 1, in this one that is become a list of lists, it will list this each string. So as I said, this will become something like that, and after it do list one of these, it becomes something like this, where each character is an item. We could have done it differently, because yeah, we could have done differently, but don't want to waste too much time, so we have done this, and let's leave it this way. So this is transformed in a list of lists in which each sublist contains an item for each character. That is a string with one character. Okay, so that we can iterate it and substitute to each character one tile. And then to make it more readable, I think I created a dictionary here, and the dictionary has 4 keys that are the symbols that are in here, that correspond to a variable that contains an object with the image that need to be substituted in the map of characters. That is the dirt, the grass rounded on the right, grass rounded on the left. Okay, using pygame.image.load. Then when we go to the while loop here, and I don't like I prefer this way of closing Pygame. using loop instead of true. Loop equal 1. Well, loop, this is just a matter of taste. And okay, in the while loop, we are gonna to split the images for the tiles here. We will create an empty list called tile rects, and these two are two counters. And for line of symbols in game map, so for each line of symbols, that the line of symbols are these. So for each one of these, and for tile in line of symbols, I could have used instead of tile for symbol. Okay, for symbol, but yeah. For symbol, in line of symbols, if symbol in TL, so if symbol is in this is the OX or this other symbol, it will just display blit the value of the L symbol. So the value of this, for example, is this. That is this. That is the image. So it will display the image, and will display the image at the position X. So the position 0, or the position yes, 0 0 at first, then 16 16 as a second, or better, 0 0 the first, 16 0 at the second, 32 32 0, and until it reaches the end of the first line, and then to 0 16 16 16, etc. So we will cover all the screen but if symbol is not equal to this one, so when it's not empty, it will also tilerex.append to this thing here. It will append the coordinates, the rectangle with the coordinates of this symbol here. It means that if it's not empty, so if it's grass, dirt, or grass on rounded on the left and right, it will pass these coordinates, this object, this rectangle object with its coordinates to this tile rex that we have seen. It is used here to see if the player collides with the tile. Okay, and we explained it before. So now you know where these tiles come from. Are the coordinates here that are stored each time for every frame in this list. So when we run it, it blitz all this thing every 60 seconds, blitz the player, checks if the player is touching on the bottom. Now on the bottom here, it means that collides on the bottom. It can jump. If it goes up, it collides with the top, so it cannot, the momentum is to 0 and the air thing is to 0. And so that is how it works. And now we could put here an exit. Yeah, maybe then some enemies, stuff like that. and make our first game like in the 80s. And okay, that's all for the moment. We've done some physics trying to explain what the fluffy potato did. It made a very nice job here, and see you to the next video, video number 3.